Okay, in this subchapter we will learn about the matrices of determinants, adjoin and rest. Okay, what is determinant? Okay, determinant, for example, we have a matrix of 2 times 2. Okay, A11, A12, A21, A22, and B is we have matrix of 3 times 3. So determinant of A, okay, for A denoted that det A, determinant A, or A there is a modulus. Okay, so the formula for A determinant is A11 times A12, okay, minus A12 times A21. So you will get the determinant of A. Meanwhile, for determinant of 3 times 3, okay, concept or the formula is first you take A11. Okay, so for example this one A11, so you can just slash the first row and the first column, so your matrix will be remaining A1, A22, A23, A32, A33. Okay, so you will get the first determinant for the first part. Then you need to minus of A22. Okay, now minus of A22. We're taking the second one, A22. So sorry, A12. So you're taking the A12. Just now A11, now A12. When you take A12, so you can eliminate the row and the column of A12. So your matrix will remain A21, A23, A31 and A33. Then plus A13. Okay, A13. When you take A13, so you eliminate the column and the row, yeah, so your matrix remain is A21, A22, A31 and A33. Then you need to solve this one expansion in order for you to get the B determinant. Okay, so big question marks. People ask the negative and positive. Why here is positive? Why here is negative? Why here is positive? The idea is before you start the determinant, you can put the positive negative first. For example, taking positive, negative, positive. So negative, positive, negative, negative. Negative is positive, negative, positive. So that's why when you take A11, so the first will be a positive. Then when you take A12, so it will be a negative. Then A13 will be another positive. So for example, you are taking not the first row, you are taking the second row as your main, A21. So you will start with negative first, means negative A21. Then the matrix will be, you will delete this one, this one will be 1A12, A13, A32 and A33. Then will be next is a positive A22. Then your matrix, then a negative again, A23. So it depends on the negative positive over here. Okay, so to make things clear, we can go for example 1. Okay, so for example, you need to evaluate the determinant of A with this type of matrix. Okay, you have A, the matrix is 1, 2, 4, negative 1, 0, 3, 3, 1, negative 2. So in order to calculate the determinant, okay, what we need to do is, first we can put negative, positive in early stage. So we will positive, negative, positive, negative, positive, negative, positive, negative, positive. So then, okay, what you can do, we can calculate the okay, so in order to calculate the determinant, so you are taking A determinant is equal to, you are taking the first one will be 1, so your metric remain is, so you eliminate this one, you eliminate this one, so the metric remain is this one, so it will be 0, 3, 1, negative 2. Okay, then plus or minus, next we are taking the second one, which is 2, but we know this is a negative, so automatically here, in order to calculate this one, it will be negative 2. Then you put the metric remaining, so in this case this one will be eliminated, this one will be eliminated, so it will remains the negative 1, 3, 3, negative 2. Then the third one will be plus 4. Okay, determinant, so okay, we will eliminate this one and this one, so what it will remain is negative 1, 0 and 3, 1. Okay, then you can start to calculate. So we know that you will have 1, okay, in the bracket of 0, 0, okay, 0 times negative 2 is 0, 3 times 1 is 3, so it will be 0 minus 3, okay, minus 2, second one, negative 1 times negative 2, so you will get positive 2, minus, okay, 3 times 3 will be 9, so you get 9. Then plus 4, you do the same one, negative 1 times negative 1 is negative 1, minus 0 times 3 is 0. So here you will get your answer of 1, negative 3, minus 2, negative 7, plus 4, negative 1. So at the end you will get here is equal to 7. Okay, this is to calculate the determinant if you take the first row. Okay, for example, we want to take the second row, that's now is first row, the second row as your reference. So you can try to check it. You have A determinant is equal to negative 1, so the first one is here, so you will eliminate this one, you will eliminate this one, so what you will get is you get negative 1, so the metric of 2, 4, 1, negative 2. Okay, so the second one will be 0 here, so it will be plus 0 times, okay, so this is your eliminate this row and this column, so what you will get is 1, 4, 3, negative 2, then you will get negative 3, okay, so negative 3, the remaining is negative 1, 0, 3, 1. Okay, so when you calculate this one, you will get negative 1 times negative 4 minus 4, then the second one will be 0. Okay, the third one will be negative 3 times 1 minus 6. So here you will get the same answer, which is negative 8 plus 15 to 7. So you will see here both answers show the same one. So if you take the third row also, you will get the similar determinant. Okay. Okay, next is adjoin method. Okay, how to do adjoin method? Adjoin method, for example, you have a matrix of A, 3 times 3, 3 to 1, 1, 6, 3, and 2, 1, 0. So therefore you need to calculate the cofactor or C for A. How to calculate the cofactor? The formula is, you are taking negative positive. First of all, you are putting the negative positive here. So we positive, negative, positive, negative, positive, negative, and positive, negative, positive. Then you are taking the first row. It's a positive, you are putting positive here. Then you put the matrix remaining. So for A11, okay, this row will be eliminated. Okay, then this row will be eliminated. So you just remain 6, 3, 1, 0. Okay, for the second row will be a negative here. So you're putting a negative here. Then you will get the remaining of, eliminate this one, you eliminate this one, you will get 1, 3, 2, 0. Okay, the third one will be positive. You are putting positive here. You eliminate this one, you eliminate this one, so we remain this one. Okay, so 1, 6, 2, 1. Okay, so just now the second will be negative, positive, negative. So the second row will be, and start with negative. Then you eliminate this row, you eliminate this row, you will get this one here. Then next is the second column, the second row will be positive, then you will eliminate this one, you will eliminate this one, you will eliminate 1, 3, 2, 0. So the next is negative. Okay, based on here negative, you eliminate this one, you eliminate this one, you will remain this one. You eliminate this one, negative 3, you eliminate this one, and you eliminate this one, you will get 3, 2, 1. Okay, so the same one in the final row. Okay, the final row continue to have a positive here, positive, negative, positive. So we positive and remaining the matrix. Okay, so eliminate the row, eliminate the column, then you have positive here and negative, then the matrix, the third one, and the matrix. So you solve this one. So you solve this matrix. Okay, so 6 times 0, this one times this one is 0, minus 3 times 1 is negative 3, so you will get negative 3. So 1 times 0 is 0, minus 3 times 2 is 6. Okay, because of this minus, so become positive here. Okay, then you will get positive 1 minus 1 times 1 become 1 minus 12, so we get negative 11. So you get, calculate everything, so you get the adjoint matrix. Okay, So the moment you get the adjoint matrix, in order for you to get the adjoint matrix, or we call it as transpose of cofactor C, okay, so therefore you need to transpose the adjoint to become cofactor transpose. So the row become column, column become row. So here is -1 3 21 1 0, so it become -3 1 0. Then 6 2 8 will become 6 -2 -8, then -11 1 16. So you transpose this one, so you will get the adjoint matrix of A, or the transpose of cofactor. Okay. This is for adjoint or transpose cofactor. So next, the next is about how to do the inverse of the matrix. Okay, in order for you to calculate the inverse matrix using adjoint method, okay, using adjoint method. So first of all, your determinant should not be 0. Okay, if your determinant is not 0, then transpose of A1 will be exist and can be written as A1 A transpose is equal to 1 divided by determinant times adjoint matrix. So for example, you have a 2 times 2 of matrix A B C D. So in order for to calculate the inverse matrix, so you use this formula, 1 divided by determinant times adjoint A matrix. So the determinant is A times D minus ABC, A times B. Then the adjoint matrix is D negative B negative C A. Okay, so this is the formula of inverse. So that's why just now we learned about how to calculate the adjoint and also determinant. Okay, so for example, before to go for this example, okay, find the A inverse if exists using the adjoint method. Okay, we go for A first. So solution for A. So you have a matrix of A. So first you need to check the determinant. So for A determinant, you will get, okay, this is your matrix 1 2 4 1 negative 1 1 1 3 5. So your determinant will be, take the first one 1, the remaining is negative 1 1 3 5, minus, take the second one 2, the matrix remaining is 1 1 1 5, plus take the third one 4, so you will get remaining 1 negative 1 1 3. So you solve this one, at the end you will get negative 8 minus 8 plus 16, so you get 0. So when you get 0, automatically we know that A determinant is equal to 0, means therefore A inverse does not exist. Okay, this is how to check first. Okay, so for example, we go the first one, we already calculate is not a there is no inverse. Okay, for example, for B, first you check the determinant. So you have a 2 to negative 1, 4 0 2, then you have 3 negative 2 1. So you have negative 2, the remaining is 0 2 negative 2 1, okay, minus 2, the remaining is 4 2 3 1, okay, minus 1, so the remaining is 4 0 3 negative 2. So when you calculate this one, you will get negative 8 plus 4 plus 8, so you will get 4. So means there is inverse of B matrix, this exists. So now how to do it? So based on next formula, what you need to do is you need to calculate the cofactor of B. Okay, what is cofactor of B? Okay, which is your cofactor of B is taking this one. You are taking the first one will be a positive, then the matrix remaining is 0 2 negative 2 1. Then you are taking the second one is negative, the matrix remaining is 4 2 3 1. Then you're taking the first one will be positive, 4 0, okay, 3 negative 2. Then same the second row will be negative, remaining is 2 negative 1, okay, negative 2 1 plus negative 2 negative 1 3 1 minus negative 2 2 3 negative 2. Then the last row will be positive, 2 negative 1 0 2 negative negative 2 negative 1 4 2 positive negative 2 2 and 4 0. This is your cofactor matrix. So when you calculate this one, you will get the matrix of 4 2 negative 8 0 1 2 and 4 0 negative 8. Okay, this is your cofactor, but we need to have a adjoin B of matrix or transpose of cofactor. So you have this C, so you need to transpose it. So 4 row become column, column become row. So 2 1 0 negative 8 2 negative 8. So this is your adjoin B. Okay, next you need to calculate the B transpose. So your B transpose will be 1 over determinant of B adjoin B. Okay, this is the formula. So just now we know that 1 over determinant of B is 4, then Adjoin B is this one will be 404 210 negative 8 to negative 8. So you solve this one, you will get 0 1 0 101 1 over 2 1 over 4 0 and negative 2 1 over 2 negative 2. So this is your final answer of B inverse. Okay, so in order to check, okay, to check and balance, is it the correct one? So if B matrix, okay, sorry, B matrix with times with B impulse, so you will get identity. So your B matrix will be negative 2 2 negative 1 4 0 2 3 negative 2 1. Then your inverse is 1 0 1 1 over 2 1 over 4 0 negative 2 1 over 2 negative 2. So if you calculate this one, you will get 1 0 0 0 1 0 and 0 0 1, which is your identity. Okay, this is how to prove it. Okay, okay, next, for example, we go for example C. So find the determinant of E matrix. E is equal to 1 2 3 4 1 5 and also 6 0 3. So first of all, you need to calculate the determinant. So in here you will get determinant of 28. Then you need to calculate the cofactor matrix of C. Okay, so try to calculate. You will get your C is equal to 2 22 negative 6 4 16 12 7 57. Okay, so next is you need to do adjoin of the matrix E or C transpose. Okay, cofactor transpose, you will get 2 negative 4 7 22 negative 16 7 negative 6 12 7. Then what you need to do, you want to find the inverse of E. Okay, so E inverse is equal to 1 over determinant E adjoin E. So you get 1 over 28. Then you're putting the matrix will be 2 negative 4 7 22 negative 16 7 negative 6 12 97. Okay, so this is your final matrix. Okay, next, maybe you can try this as your example. Okay, this is one of a simple 2 times 2 inverse matrix. Okay, you can refer the notes, and also another one, you can do this example to prove it that how this method works. Okay. Okay, thank you.